Greetings, human viewers. My name is Dr. Beaker, and me and my human underlings, Sam Cohen and Ryan Pinchbeck, will be presenting our experiment on the role of NAD+ in biological oxidation reactions. The purpose of our experiment is to understand the concepts and properties around 4 key substrates and how they are oxidized in the presence of NAD+ and affected by malinate. For our experiment, 16 tubes were prepared as shown by our table. 4 control tubes containing no hard extract were prepared for comparative purposes, while the remaining 12 were split into 4 groups of 3. Each group of these tubes represented their own substrate, these being pyruvate, malate, succinate, and lactate. Each group then had 3 tubes with different treatments, one without NAD+, one with NAD+, but without malinate, and one with NAD+ and with malinate. To prepare the heart extract, we start with 5 grams of heart muscle freshly obtained from an unwilling sacrifice. The heart is then sliced and diced with a scalpel before being transferred to a beaker and washed with cold water 3 times. The heart mince was then poured over a muslin cloth, retained, and squeezed to remove any excess fluid. Then we transferred the mince into an ice-cold mortar, chilled on more ice, and added 6 ml of ice-cold phosphate buffer and a teaspoon of the finest Arabian sand. After this, much like an ex-lover, we mashed and pulverized our heart until it was a fine paste. We then add 20 ml more phosphate buffer, mix it well, and pour into a large chilled test tube. Once the sand settled, the suspension was decanted through muslin cloth into a large chilled test tube. This totaled around 17 to 18 ml of heart extract.
Our results were a little unexpected. The DCIP in our experiment took longer than expected to change colour compared to the expected results. However, the order at which the various substrates went colourless was as predicted. First to lose its colour was the succinate solution, followed by lactate and then malate. Pyruvate did not cause the DCIP to lose its colour. The succinate solution that contained malinate lost its colour at a significantly slower rate than did the solutions of succinate without malinate. The malate and lactate solutions that did not contain NAD did not lose their colour. Succinate does not use NAD as its carrier molecule, but uses FAD in place of NAD. This meant the oxidized succinate's electrons were quickly passed to the DCIP, bypassing carrier molecule transport and the rest of the Krebs cycle, and the blue colour was lost. In the presence of malinate, the succinate solution took longer to oxidize as malinate inhibits the action of succinate dehydrogenase, which is the enzyme that oxidizes succinate in the Krebs cycle. The succinate was not saturated by malinate, and so the reaction still occurred, but at a reduced rate. The malate and lactate solutions that did not contain NAD did not lose their color as they did not contain any carrier molecule to transport their electrons to the DCIP. This obviously meant that the DCIP could not be reduced and hence retained its blue color. We were tasked in performing the experiment to answer several questions. 1. The heart extract was unable to oxidize any of our substrates in the absence of NAD, with the exception of succinate, as the molecule upon oxidation does not require NAD to transport its electrons. 2. Upon addition of NAD, the substrates, with the exception of pyruvate, were oxidized by the heart extract. This is because pyruvate requires the presence of oxygen to enter the Krebs cycle to be oxidized, as well as various cofactors that weren't present in the given solutions. 3. As explained earlier in the description of the succinate solutions, the malinate inhibited the oxidation of the succinate, but not enough to cease the reaction entirely. Tubes 1 through 4 were used as controls. These tubes did not contain any of the substrates, but did contain different combinations of NAD and malinate. Tube 1 containing neither, 2 with just malinate, 3 with NAD, and 4 with both. These controls were put in place in order to observe whether or not there was color change in the absence of substrate. 5. All substrates except the pyruvate were oxidized. 6. The only substrate that was not oxidized under any of the experimental conditions was pyruvate, reasons for which explained under question 2. 7. In the absence of NAD, the lactate did not become oxidized. However, succinate did. The enzymes that oxidize lactate require NAD to take the electrons released. Succinate does not require NAD, and so in its absence was still oxidized. The rate at which our solutions change colour was much slower than what was expected. This is most likely due to poor mixing of solutions prior to incubation.
So, there you have it. Thanks to the work of my human underlings, the oxidation of substrates and their dependence on NAD+ have been examined. Science solved. And they call me a quack.